Welcome again to Code and Power Out. For those who've joined us, welcome. For those who are in the series, let's proceed. The series is made in a way that each video is independent of the other, but I highly recommend that you watch them in the playlist. So in our previous video, we had created what we call a repository pattern. So where we had about 5 operations on our to-do item. So we have our repository. Then we went ahead to implement that using our database context, where we had the add items, how do you delete an item, we had getting an item by ID, getting all items, and also updating an item. We have our to-do item, so it's just what entails to a task, and we have our context, which has one table for now. Then finally we have our controller, where we are using the repository to talk to our database. And we said that the repository gives us the ability to manage our data access centrally, so that there's a single place, a central place where we can talk to our database. We don't want to be talking to the context everywhere we want to talk to the database. So the repository is going to give us that abstraction. But as developers, as engineers, we can take it a step further and say, okay, this repository we have, you see it's tightly coupled to one item, and that's a to-do item. The question is, what if we had so many objects, which we'll have as we go down this path? It means I would have to have a repository for to-do item. Then I might have one for the users. I might have one for things like maybe alerts, and I would have to really duplicate all of this. So as developers, we're trying to find ways to make our code scalable, make our code maintainable, and make our code readable and reusable. So we'll take it a step further and introduce what we call a generic repository. Now, this is a repository, but this is not generic, it is specific. So what is a generic in C#? All we are saying is we want to have a flexible and a reusable way to interact with data access layers in our application. So what are we pretty much going to do here? We'll see there'll be abstraction. This abstraction is already given by this interface, this repository. But what a generic would do is it will now abstract away all the underlying access from the details that are implementing. Then it will give the rest of the application the ability to interact with the data in a consistent manner. Whether the data is in a database, a web service, or any data source, it will still give us a consistent way. If you go to get to do items, you will not care how it was implemented. It could be talking to another API, it could be the database, but the way we'll get that item will be consistent each and every single time, and the code will be reusable. The problem with this is you cannot reuse this code for another object except for to-do item. So a generic repository will allow us to use the same repository over and over without really changing. So a single implementation is going to allow us that. I've talked about consistency. There are common operations we have on our data sets, and we call them CRUD operations: create, read, update, and delete on entities. So if we have a general way of doing that, then we'll promote consistency throughout our application. And the other thing is we'll bring in some decoupling. So we use this generic repository to decouple the business logic from the data access layer. We want to put it in one, and we call this separation of concerns to make these things easier to maintain, to test, and as it changes, and you'll see in this series, we will be able to anticipate that change. And finally, we'll see a thing called dependency injection. We've looked at it briefly in our previous video. We had brought in this repository here to show you how it works. So the thing is, the generic repository will be easily integrated with dependency injection framework, and we can swap data access like we did in the last video. So overall, this will provide with us a clean and efficient way to manage data access operations in our application. It will promote code reusability, maintainability, and flexibility. But enough of the theory. Let us get down to business. So the first thing you have to do is to bring that contract, which will show the generic. So I'm going to go to the repository, then I'm going to create a class. And we're going to call this class, okay, rather, let's create first an interface, and we'll call this class an generic repository. So I'm assuming you're familiar with generics in C Sharp. What they do is we can just anticipate that uh, this function is going to accept an object, and whatever object you give it, it's going to be able to know it in real time and use it. So we will show that by putting T. And T means we'll go further and say T is going to be a class, where T is class. So we're saying that we're going to give you any object, just ensure that object is a class and deal with it. The problem with our I repository is it wasn't a generic. We would have done a T there to say anticipate something, but this was specific to an actual object. So this was limiting. But with a generic, if you just say T, it doesn't care what it is beforehand. You can give it as long as it's a class. And we want to have a few functionalities, obviously. We want to have one to get or, we want to get by ID, we want to add, we want to update, and we want to delete. So we want these 5 things. And you can see the T there, it's generic, whatever you're going to give it. And once you finish the generic, we would want to implement it, the concrete implementation. For now, we use the database context which we have, but just to show you that we can take it a step further, we're also not going to tightly couple our generic to this context. We're going to say, give us a context in real time, or as your app runs. So let's create a class. We'll call it generic repository, which will now implement what we're doing. So we'll get the class, and this class is going to make it clear that this class will also expect a generic, and this class is going to implement from an I generic repository where the T is a class. But obviously it will say it's a contract, so give us what we need. So we're going to press Control dot and say implement it. But I want to take this a step further and make it even more dynamic. So I'm going to have the database context to also be dependent on what you're going to give it. So I'll bring in a constructor. So ctor is a snippet. In this constructor, I want to have a DB context. So there are 2 ways to do it. I could say, give me a to do database context like so. So it means this generic repository is going to always rely on this repository. But what I'll do is I'll take it a step further and say, just give me a DB context. And this DB context is from entity framework call, right? So DB context. And then what we can do is also say, bring that as a property, as a field to say, okay, fine. So give us a context. Okay. Underscore. There's also something that we would want to do. That is to have access to the tables. And remember, in our context, we have what we call a DB set. So we also need to have a DB set that will enable us to have access to that. So a DB set already. So we're going to have a DB set. But before we do that, let's bring it up here. I'll make it protected because I want to access it outside also, and you see why. So I'll say DB set of a DB set. Then here I'll say DB set, get the context and set. There we go. Then our next order of business would be to add an entity. So how do you add an entity? Very simple. We'll just get the DB set itself, and we're going to attach the entity which you give us. Then you need to save those changes if the entity framework is going to save that. DB context, DB context, and you're going to save those changes. That should enable you to do that. Then we have delete. For us to delete, we need to ensure that we have an entity. So save our entity. I want you to go on the DB set and find base of an ID. And if the ID is not equal to null, then we want you to get on the DB set, remove that entity, and save those changes. Then if you want to get all, since get all will just be a single line, we can be a little bit neat. That's what programmers do. Well, you're going to say, I'll use this. Let's use the modern C# features. We'll just get a DB set and just throw whatever we have to list. That's enough. Then we'd want to get by ID. Once again, if you want to get by ID, we would have to see. So we'd say, let's be neat again. Since that could be one line, might as well just say DB set dot find the ID, and just find should be enough. Give us back, it'll complain of the now set, and then we can enhance it later. If we want to update, we'll just say get us the DB set, and let's attach the entity itself. So attach the entity. But unlike the add where we're attaching and saving, here we need to see if the state has changed. So I'll play on the context. Then we'll say on the context, we want to see if the entity state has changed. Anything within that entity has changed. So entry. Then check our entity. So let's check its state. If the state is modified, then something has changed. Then proceed to save your changes on your context. To db context dot save changes, like so. Right. So we've done our DB context, we've done our DB set, but we need to now add this to our dependency injection container so that we can be able to just call it from the container. So we'll go to program.cs, and what we'll do here is we'll say, let's add a generic dependency injection. And since it's a generic, we're going to say builder add scoped the type of generic repository that goes to this actual implementation. But remember, in our generic repository, we have said this is general. So we also need to register what we want our database context to be in this class. We need to do register our database context, our DB context. Okay. And what we'll do there is we'll say builder dot services. It'll be scoped again. Then we'll add scoped. Then we're going to say type of DB context is DB context, and we see that it is complaining. It says what? Add scoped. Okay, that should be a spelling issue. So they're saying whenever you see the DB context in this scenario, use that, because we can have multiple contexts within our application. Now we'll go back to the controller and also change. We had the to do item repository. We are going to remove it for now, and we're going to say private generic repository, and we want to play around with it to do item, and we're going to bring this into the constructor. So let's add that to the constructor. So it's going to be an I generic repository, which is going to play with the to-do item. And now we see that a lot of things are throwing errors, and that should be expected. So for us to get everything, we'll go to the item and we'll say we have our get by ID. So we'll say dot get by ID. Okay, now the first one is get, so this should be get all. So it will be get all, like so. So we get all, then we'll return whatever item is there. But for those who like to keep the code short and precise, I wouldn't blame you if you prefer to do it like that. You could just return an OK. Return it OK. For us to get a single item, we're going to use get by ID. Get by ID. Then the rest would be the same. If you'd want to add, then you have the add method. Okay, then you might want to go ahead and edit. So you get that. Then what you do here is you say repository dot okay dot update, and there you have it. Then you can have repository dot delete there and there. So we'll try to run this and see if we get the same. All right, so if we try to get the task, it gets whatever task we had. So that's brilliant. I'll just try two. Let's try to add a task. We'll call that shopping. We'll call that library. We want to prepare for midsem, and we'll leave it like that. Then we execute that, and we'll see that that's created. If I try to go and get the ID for there, I should get that as well. Okay, there we go. So we have implemented our generic repository, but I always get a question to say, sometimes life is more than CRUD. Yes, over 90% of what we do is CRUD, but what if we wanted to have something specific to the to-do item? How do we go about it? How do we do it? So what we do is, if there's something that's specific to a to-do item, then we create a repository that is specific to that, but it will inherit from the generic repository. So what you do is you create an to-do item repository, which we have here already. So I'm going to remove all of that, and say, for instance, you want to have getting all completed items. So I can say return an enumerable of to-do list, to-do item. Then I'll call this get completed items, for instance. So this one is specific to this guy. It's not to do with the generic repository. Then what you do here is you say, on this to-do item, I want to inherit from the generic repository, and I want to give it. So this one will have access to all of this, as well as whatever's happening there. Implement this. So we had that the to-do repository, which had all this. So again, I'll go forth and I will comment out everything from our previous tutorial, and I'll say let's comment that out. Then this is going to now inherit from the generic repository of the to-do item, and it will complain to say give us that thing, and we are going to bring that add get. Okay, my apologies. We're supposed to inherit from two, So we inherit from this as well as the I to do repository, like so. Then we're going to implement the interface. So this will just bring us, okay, let me just remove what it came with those. All right, so we can inherit from an interface, we inherit from a class. So there we would need to get the generic repository and that, so that we only have this one thing. So not that as well. This one can go. All right. Then for us, in our repository, we are going to give it the same DB context, so that we keep it generic. Give it the same DB context, and we need to give the context to our base context as well, so that it goes to that generic repository, and we have that to do context there. And for us, here is where I said we need to keep our DB set protected so that we can access it within the same library. So I will go back here and I'll say kindly return return the DB set, okay, dot where we have the item and where that item is completed is true, and throw us that item to the list. Then I will go to my controller, but for me to access that, I also need to bring it as a dependency. That's why I left it there. So you want to have it there, private repository, but I'll call this one a to do repository so that I can distinguish that. Then I need to have this in my, add this parameter in my constructor, like so. Then I can add an endpoint. I can call this HTTP get. I'll call this completed. Then we can say public action result. It's going to give you a list of the to do items and return OK and get me all tasks that are completed. Then I can go ahead and, so we have an error. Interesting. Where is it coming from? I know why. In our previous video, we had brought in the new database way so that we show you how we can just swap these things without changing code. So I'll just remove that, and I would run this again and see. So it loads. We have that get, and if we try that out, it should go and get us tasks that were completed, and we have these 2 tasks. So there we have it. A simple way to make your code reusable, maintainable, and testable, everything that you have it. But it's also a good way to abstract and keep your things centrally. So if you enjoyed this video, please give it a thumbs up, please share, but most importantly, support us with at least $3 on Patreon so that we can have time to provide more content that will help people out there. Have a good night and happy coding.